So in this lesson, we're going to be looking at the electronic configuration of different atoms. But the first thing I'd like you to do is quickly answer true or false for these statements here. This should take you no longer than 2 minutes. So going through this quickly, make any corrections you need to in green pen. So the number of protons is always the same as the number of neutrons. That is false. The number of protons and number of electrons has to be the same in an atom, but the number of protons and neutrons does not. Most of the atom is empty space. That is true, which is what Ernest Rutherford found when he fired the alpha particles through the atoms of gold. The majority of them passed straight through. Most of the mass of the atom is in the nucleus. That is true, because it is the protons and the neutrons that have the majority of the mass. Remember, electrons have negligible mass. The electron is the heaviest subatomic particle. That's obviously false. It is the lightest. It weighs 2,000 times less than a proton. And finally, the mass number is the total number of neutrons and protons in the nucleus. That is true. In fact, the mass number is sometimes called the nucleon number because it is the mass of the nucleus, because that's where all the mass is. Because again, the electrons have negligible mass. So what we're going to be looking at, so we've talked about generic atomic structure in terms of protons, neutrons, and electrons, and how to find out how many protons, neutrons, and electrons there are. And we've now also spoken about isotopes, where we have variation in the number of neutrons in the nucleus. But now we're going to talk about the electrons and the way they are arranged. Now, this term at the top, electronic configuration. So electronic is referring to electrons, and configuration is the organization or structure. So that's all electronic configuration is. How are the electrons organized within the atom? So there are three things that we need to consider when talking about electronic configuration. We need to know the total number of electrons and protons in the atom. We need to know the number of energy shells that the atom has, and we need to know how many electrons are in each of those shells, and it's particularly important that we know how many are in the outer shell. So you could be asked to draw or write the electronic configuration for the first 20 elements, so that's hydrogen to calcium. You wouldn't be asked to draw the electronic configuration for any of the other elements. So there's 118 elements, but you're only ever going to be asked to do this for the first 20, hydrogen to calcium. So we need to be able to work out how many electrons there are, and we should already be familiar with that, and that is to use the periodic table to find the atomic number, which tells us how many protons we have, and we should know that the number of protons is equal to the number of electrons. So we should be able to work out our total number of electrons. And it's important that you understand how energy shells work. So as you go away from the nucleus, there are more and more shells of electrons, and they have a maximum number of electrons they can hold, and they always fill up the closest to the nucleus first. So the first shell, which is the shell closest to the nucleus, can only hold 2 electrons. So once you have 2 electrons in that first shell, the additional electrons will now go into the second shell, which can hold 8 electrons. And then once that second shell has 8 electrons in it, then any additional electrons will go into the third shell, which again can hold 8. And then once that's full, the fourth shell, which again can hold 8. But in reality, because we're only ever going to go as high as calcium, calcium has 2 in the first shell, 8 in the second, 8 in the third, and only 2 in the fourth. So sometimes you might see this written in textbooks or revision guides as 2882, and that's purely because you're only ever going to need to go as high as calcium, which means the most electrons you're ever going to actually need to put in that fourth shell is 2. So I'm just going to put that in brackets just in case you see that written somewhere else. So we've got 2 elements here. We've got oxygen and magnesium, And we've got two things. We want to draw the electronic configuration and we need to write the electronic configuration. Now, in terms of drawing it, we don't need to draw all the protons and the neutrons. We simply need to identify that this atom is oxygen and this atom is magnesium. So we need to work out, first of all, how many electrons oxygen has. So oxygen has an atomic number of 8, which means it has 8 protons, which means it has 8 electrons. So in the first shell, I can put 2. So I'm going to put 2 electrons there. And I need 8 in total, so I need another 6. And they are all going to go in this second shell, because remember the second shell can hold a maximum of 8. So 6 are going to fit quite nicely. And we're going to fill them up like this. 1, 2, 3, 4, 5, 6. And the reason we do this, I mean, there's nothing stopping you putting 6 completely evenly spaced electrons in this outer shell. But when it comes to marking these, the examiner, it's going to be much easier for them to say, right, there's 2 in that shell, 2, 4, 6. Nice and easy to count, easy to see where your electrons are. Okay, so while you don't have to, it is good practice that in the first shell you do top and bottom, and then in all the other shells, the ones that can hold 8, you only put the electrons in 4 different places and pair them up when you need to. So if we needed 8, we'd do 2, 2, 2, and 2. So just to double check we got that right, we've got 1, 2, 3, 4, 5, 6, 7, 8 electrons, which matches with our atomic number. Now, if we wanted to write that, it's as simple as how many electrons are in the first shell? 2. And how many are in the second shell? 1, 2, 3, 4, 5, 6. So the written electronic configuration is just 2, 6. Magnesium has an atomic number of 12. So it's got 12 protons, which means it has 12 electrons. So in our first shell, we're going to have 1, 2, because that's the maximum you can put into the first shell. But we still need another 10 electrons. So in our second shell, we can only put 8. We can't put all 10 in the second shell. We can only put 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 and 2. I need 2 more. 1, 2 for magnesium. And again, we can just double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That matches the atomic number, so that must be correct. And if we want to write it, how many are in the first shell? 2. How many are in the second shell? 8. And the third shell is 2. So this is the drawn electronic configuration, and this is the written electronic configuration. And remember, the electronic configuration, the important points are the total number of electrons, which is the same as the total number of protons, meaning that your atomic number tells you how many you need. The number of energy shells, and again, you fill them up, 2 in the first shell, then 8 in the second, 8 in the third, 8 in the fourth, and you keep filling up until you've got the correct number of electrons. And the number of electrons in each energy shell. Again, it's really important that we're getting the correct number in each shell. We don't put more than 2 in the first shell, and we don't put more than 8 in any of the other shells. So what I'd like you to do on this page is to complete the electronic configuration for the first 20 elements. So we have hydrogen all the way down to calcium here. Now, I'm going to do 4 of them, and I expect you to be able to do the rest. So I'm just going to show you how to do 4, and I'm going to do a range of them. I'm going to do hydrogen, carbon, sodium, and sulfur. And I'm going to show you how to make sure you get it right. So we start with hydrogen. So we find hydrogen on the periodic table. It has an atomic number of 1. Therefore, it must have 1 electron. Nice and simple. The second one I'm going to do is carbon. Again, find it on the periodic table. So carbon is here, atomic number of 6. So it's got 6 protons, which means it's going to have 6 electrons. So in the first shell, we can only put 2, which means we need another 4. So it's going to be 1, 2, 3, 4. Add them up. 1, 2, 3, 4, 5, 6. and that equals the atomic number of 6, so it must be correct. The third one I'm going to do is sodium. Find sodium on the periodic table. It's here, atomic number of 11. So we're going to put 2 in the first shell, which means I still need 9 more electrons. I can't put all 9 in the second shell. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, which gives me 10 in total. I need 1 more that needs to go into that third shell. Again, add them all up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which matches the atomic number for sodium. And finally, I'm going to do sulfur. So find sulfur on the periodic table, and it is here, atomic number 16, so it's going to have 16 electrons, and again, it's going to be 2 in the first shell. I still need 14. I can't put all of those into the second shell, so I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, but I still need another 6 electrons. 1, 2, 3, 4, 5, 6, and then we just add them all up to make sure that that adds up to the right number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and the atomic number for sulfur was 16. So 15 minutes will be more than enough time for you to complete the electronic configurations for all of these elements, hydrogen to calcium. I've obviously already done 4 of them for you, and if you finish before the end of the 15 minutes, then you can write the electronic configuration below. So for example, hydrogen would simply be 1, because it's only got 1 electron in the first shell. Carbon, it's got 2 in the first shell, and then 4 in the second, so it would be 2, 4. Sodium, it's got 2 in the first shell, then 8 in the second, then 1 in the third, so it would be 2, 8, 1. And sulfur has 2, and then 8, and then 6. So if you are finished, so if you've drawn all of the electronic configurations and you still have a little bit of time, then you can write the electronic configurations underneath. Okay, so I'm just going to go through all 20 of these, and if you need to make any corrections, then do that in green pen. So helium, if you look at the periodic table, has an atomic number of 2, so it's going to have 2 electrons, which fills its first shell, which if you wrote that electronic configuration, it would simply just be 2, because there's 2 electrons in the first shell. Lithium has an atomic number of 3, so it's going to have 1, 2 in the first shell, because that's the maximum the first shell can hold, meaning that that third electron needs to go in the second shell. So this would be written as 2, 1. Beryllium has an atomic number of 4, so it's going to have 4 electrons, 2 in the first shell, because that's how many it can have, and then in the second shell, again, another 2. So this one would be written as 2, 2. Boron has an atomic number of 5, so it's going to have 1, 2 in the first shell, and then 3, 4, 5 are going to have to go in the second shell. So this one would be written as 2, 3. Nitrogen is got an atomic number of 7, so it's going to have 2 in the first shell. It still needs another 5, and they're all going to go in the second shell. 1, 2, 3, 4, 5. So this one would be written as 2, 5. Oxygen, atomic number of 8, so 2 in the first shell, and the remaining 6 are going to go in the second shell. So this would be 2, 6. Fluorine has an atomic number of 9, so again 2 in the first shell, meaning 7's left over. So 1, 2, 3, 4, 5, 6, 7, and this one would be written as 2, 7. Neon has an atomic number of 10, so you're going to have 2 in the first shell, and then you're going to have the maximum in the second shell. You're going to have 8. and that would be written as 2, 8. Magnesium has an atomic number of 12, so 2 in the first shell, meaning I need another 10. I can't put all 10 of them in that second shell, I can only put 8 of them, meaning I've got 2 left over, which are going to have to go into that third shell. So this one will be written as 2, 8, 2. Aluminium, atomic number of 13, so 2 in the first shell, 8 in the second shell, giving us 3 more electrons we need to use, 1, 2, 3 in that outer shell. This should be written as 2, 8, 3. Silicon, atomic number of 14, 2 in the first shell, 8 in the second shell, and then that gives us 4 more electrons to put into the third shell. 2, 8, 4. Phosphorus, atomic number 15, 2, 8, and then we're going to have to put 5 electrons in that third shell. 2, 8, 5. So chlorine, atomic number 17, so 2 in the first shell, 8 in the second, and then 7 electrons need to go in that third shell, making this 2, 8, 7. Argon, atomic number 18, so that's 2 in the first shell, 8 in the second, and also 8 in the third. 2, 8, 8. Potassium, atomic number 19, so 2 in the first shell, 8 in the second shell, also 8 in the third shell, giving us 18 electrons. We need 1 more, goes into the fourth shell. So 2, 8, 8, 1. And then finally calcium, atomic number 20. So it's going to have 2 in the first shell, 8 in the second shell, 8 in the third shell, and then it's going to need 2 electrons in the outer shell. 2, 8, 8, 2. So here I have a table showing the group number and period number of some different elements. And just to be clear, the group number is the vertical column. So group 1, group 2, group 3, 4, 5, 6, 7, and group 0. And the periods are the rows. So the hydrogen and helium is the first row, that is period 1. Lithium to neon is period 2, sodium to argon is period 3, and so on. So the rows are periods and the columns are groups. And what we have here is a table showing the group number and the period number of these different elements. So calcium is in group 2, period 4, which tells us that it is in the 1, 2, 3, 4th row, that's why it's period 4, and it's in the second column, which is why it is group 2. We have oxygen, group 6, period 2, so it's in column 6 and it's in the second row, so it's in period 2, so group 6, period 2. So for each one of these you've got the group number and the period number. Now what I would like you to do is to look at the group number and the period number and then have a look at the electronic configurations that you have drawn for those elements, and see if you can see any correlation between the group number and the period number and its electronic configuration. So is there any link between the group number of an element and its electronic configuration? And is there any link between the period number and its electronic configuration? So looking at these elements here, calcium, oxygen, hydrogen, boron, chlorine, potassium, look at their group number and their period number, compare that to its electronic configuration and see if you can come up with the pattern that links group number and period number to the electronic configuration of that element. So hopefully what you found is that the group number tells you how many electrons are in the outer shell. So we look at calcium, group number 2. Well, calcium has 2 electrons in the outer shell. If we look at oxygen, group number 6, well, oxygen has 6 electrons in the outer shell. Hydrogen, group number 1, hydrogen has 1 electron in the outer shell. Boron, group number 3, and again 3 electrons in the outer shell. Chlorine, group number 7, 7 electrons in the outer shell. And finally potassium, group number 1, 1 electron in the outer shell. So the group number tells us how many electrons are in the outer shell of the atom. The period number tells us how many shells there are. So if we look at calcium and potassium, they are both in period 4, and calcium and potassium both have 4 shells. Oxygen and boron are both in period 2, meaning they should have 2 shells. Oxygen, 2 shells, boron, 2 shells. Hydrogen is in period 1, which means it should only have 1 shell, which it does. And finally, chlorine is in period 3, so we should see 3 shells for chlorine, 1, 2, 3. So in terms of reading electronic configuration from the periodic table, there are 3 things we can do. We've got the atomic number, which tells us the total number of electrons. Because the atomic number tells us how many protons there are, and the number of protons is equal to the number of electrons. So whatever the atomic number is, that's how many electrons we have in the atom. The group number tells us the number of electrons in the outer shell. And the period number tells us the number of shells. So what I'd like you to do quickly is you have some elements here. Using the periodic table, identify their atomic number, their group number, and their period number, and then write their electronic configurations. This should take you 5 minutes. So I'm just going to run through the answers, make any corrections that you need to in green pen. So we'll start with sulfur. So we'll just find it on the periodic table quickly. Has an atomic number of 16. So we know it's going to have 16 total electrons. It's in group 6. So we know it's going to have 6 in the outer shell. And it's in period 1, 2, 3. So we know it's going to have 3 shells. So it's got 3 shells. The first one's going to have 2. And the second one's going to have 8, and the third one is going to have 6. Double check that that all adds up. 2 plus 8 is 10, plus 6 is 16. The next one is phosphorus, atomic number 15. So we know it's going to have 15 electrons. It is in group 5, so it's going to have 5 electrons in the outer shell, and it is also in period 3, so it's going to have 3 shells. So again, the first shell will be 2, the second shell will be 8, and the third shell will have 5. Check that that all adds up. 2 plus 8 is 10, plus 5 is 15. Sodium, atomic number of 11, so it's going to have 11 electrons. Group number, it is in group 1. It is in period 1, 2, 3. So again, 3 shells, so the first shell is 2, the second shell is 8, and the third shell will have 1, because its group number is 1. Check that all adds up. 2 plus 8 is 10, plus 1 is 11. Aluminium. So aluminium, atomic number 13. Group number is 3. Period is again 3. So our electronic configuration for aluminium will be 2, 8, 3. 3 shells, 3 in the outer shell, and it all adds up to 13. Finally, helium. So helium has an atomic number of 2. So it's going to have 2 total electrons. It is in group 0, and it is period number 1. Now here, we're going to see something different, because it's got 2 electrons and it's got 1 shell, so it's just going to have 2 in that shell. So why is its group number not 2? And that's because if we look at our electronic configurations that we drew before, and we look at the elements in group 0, so we've got group 0 elements are helium, which we've got here, with 2 electrons in the outer shell, not 0. We've got neon, which is the next element in group 0. Again, doesn't have 0 in the outer shell, it has 8. And we even have argon, the next one down. Again, has 8 in the outer shell. So none of these have 0 in the outer shell. So why are they called group 0? That's because they have a full outer shell. Remember, the maximum the first shell can hold is 2. So helium has a full outer shell. The maximum the second shell can hold is 8, and neon has 8, so it has a full outer shell. And argon, again, the third shell can hold a maximum of 8. Argon has 8 in the outer shell, it has a full outer shell. So that's why it's called group 0. It doesn't mean they have 0 electrons in the outer shell, it means they have a full outer shell. So finally, we have a 10-question facts test. Again, all questions from this topic and the previous 2 lessons. You have 10 minutes to complete those. Okay, so I'm going to go through the answers here. Just mark the ones you get correct. The ones you get incorrect, just correct them in green, and then at the end give yourself a score out of 10. So what name is given to the smallest part of an element? That is an atom. Why is the number of electrons the same as the number of protons in the atom? They are oppositely charged. Therefore, they cancel each other out, which is why the atom has no charge overall. An element has 3 shells and 7 electrons in the outer shell. What element is it? So, if it's got 3 shells, it must be in period 3, and if it's got 7 in the outer shell, it must be in group 7, so period 3, group 7 makes it chlorine. How many protons are in an isotope of chlorine-35? Well, it doesn't matter that it's an isotope, it's still chlorine, which means the atomic number of chlorine is 17, so it must have 17 protons. What does the mass number of an atom represent? It is the number of protons plus neutrons. Remember, we do not include the electrons in the mass because they are so small. What is the relative mass of a proton? It is 1. How many electrons does an atom of calcium have? So let's find calcium. Atomic number 20, so 20 protons, meaning it will have 20 electrons. how many electrons can go into the second and third shells? So the second can hold 8, and the third can also hold 8. How do you calculate the number of neutrons in an atom? It is the mass number minus atomic number. Because remember, the mass number is the number of protons and neutrons, the atomic number is just the number of protons, so if you take the atomic number away from the mass number, you are just left with the neutrons. And what does the atomic number of an atom represent? It is the number of protons. So again, make any corrections that you need to in green pen and give yourself a total out of 10.